This is a lesson to teach you about how we use our TCAP practice workbooks. One of the things I like to do is, instead of waiting to the end of the year and doing a 3-week full-on blitz of TCAP practice, is every time we finish studying something, I'll give you a few TCAP practice questions on that topic to see if the TCAP were that day, how would you handle it? Would you be able to get it right? This gives me some great information. Maybe I need to go and teach you some more, maybe you're ready to move on. So the resource that we use for this is these TCAP practice workbooks that came with our textbook. You know, the textbook that we don't really use in class. These are great. They're worth their weight in gold. The questions in them are really close to the real thing. In fact, I think they're a little bit harder than the ones on TCAP. So if you do okay on these, TCAP's going to seem easy to you. You may remember at the beginning of the year we set up a TCAP practice section at the end of your scientist notebook. So that's where you'll be doing this. What I typically do is a few questions with you together, and we'll talk about how to approach that type of question. And then after that, I'll turn you loose to do some on your own. And I will take a score on those so we can sort of measure how well you're doing on TCAP style questions on that topic. So you'll need to get one of these, and you'll need to get your scientist notebook and a pencil. So in the TCAP workbook, you need to turn to page 5. And in the TCAP practice section, go ahead and write down number 13. If this is your first time doing any TCAP practice, one of the things you'll need to decide about is how you want to lay everything out. We're going to be doing this a lot of times, so you'll need to try to fit about 4 sets per page. You'll only be writing the letter of the answer as you do, so you don't have to worry about having a whole bunch of space, but you want to try to keep it from getting too jumbled because somebody else will be grading it, and you want them to be able to see what they're doing. So in the TCAP workbook, turn to page 5, number 13. I want to do this one with you. It says, Juanita noticed droplets of water on a spider web one morning. Have you ever noticed that before? Got up in the morning and saw a spider web with drops of water on it? Time out. One of the things you need to do when you take these types of questions is think about what they're saying and relate it to your own real-life experiences. Is this something that's ever happened to you? It helps your brain make connections between your life experience and what we're doing in class. You can put it all together and really have a great chance of getting the question right. So it says, she saw in the morning news that it was cool and dry the night before. Which best describes Juanita's observations? Now, as we go through these answer choices, one of the things you'll start to see is that usually they have one crazy answer choice. And then sometimes they'll have one that's semi-crazy. They'll have the right answer choice, and then they'll have one that's wrong, but it's one that kids would commonly pick if they were confused about a certain aspect of that question. So when we look at these choices, see if you see the one that's the crazy one. So look at F. It says, water vapor from the air condenses on the web, forming water droplets. G. It really had rained the night before, but the weather reporter gave the wrong news. H. Water from nearby trees leaked out onto the web. J. Water from the ground evaporated on the web. Do you see the crazy one? Yeah, look at H. That is crazy. Water from nearby trees leaked out onto the web? That's not a thing. They're hoping that some poor kid somewhere will remember the water cycle picture from last year where it talks about how trees put water back into the atmosphere. But they don't put it like that. It's not trees leaking water. It's releases water vapor into the air. So H we can get rid of. What about G? It really had rained the night before, but the weather reporter gave the wrong news. Now, they get it wrong sometimes, but that's really probably not what happened. So now we've narrowed it down. We have a 50-50 chance of getting it right now. F or J? Look at J. Water from the ground evaporated on the web. What's evaporation? Oh, if you remember, evaporation is when you have a liquid turn into a gas slowly at the surface. If the liquid's turned into a gas, would that make drops of water be on a spider web? No. So the best choice is F. Water vapor from the air condenses on the web, forming water droplets. In fact, remember condensation is gas turning back to a liquid. So that would make sense if there were water vapor in the air at night when the temperature drops. It cools off and turns back to liquid and lands on things, like spider webs. So the best choice is G. Excuse me, F. Now everybody sees how it really is in my class. F is the best choice. Let's do another one. Now go to page 13, number 36. Now this PDF here is a little off, so my numbers will be a little different. You do the number I'm telling you, page 13, number 36. So in your TCAP practice section, write number 36. And let's look at this one. Which of the following decreases the rate at which a substance melts? First of all, let's look at that question. What does decrease mean? Go up or go down? I always help myself remember by the D in decrease and the D in the word down. Yeah, that means go down. And what did we say rate means? Rate means speed. So which of the following slows down the speed at which a substance melts? It's going to melt, but we want it to slow down. Let's see. Decreasing the temperature, B, increasing the temperature, C, increasing humidity, or D, decreasing the pressure. Which one do you think might be the crazy one? If you said D, decreasing the pressure, that is pretty crazy in our discussions. Now, we've not talked about pressure with state change, and that probably won't come until high school. But there are some things with pressure that can affect state change. But one of the things you'll need to do on TCAP is trust me, because if something's going to be on TCAP, I will do my best to make sure you've at least heard of it. So we can get rid of D. Now one of them on there, we've talked about it, but not with melting. C, humidity. We've talked about humidity. Humidity can affect how fast something evaporates. Remember, if there's already water vapor in the air, that can slow down evaporation. So we can get rid of C, which leaves us to A and B. Which one would make something melt slower? Decreasing the temperature, increasing the temperature. Suddenly this question is super easy. Yeah, A, decreasing the temperature would make it melt slower. So the best choice is A. Now, go to page 17. We're going to do number 51. Read number 51 to yourself, and then put your answer. Pause the computer if you need more time. Now, let's look at it together. Marissa saw a muddy puddle in the street in the morning. By 2 o'clock, the puddle had disappeared. Has that ever happened to you? You saw a puddle earlier in the day, and then later on it was gone. It says, which is the best inference about what happened? You might have heard that word inference or infer in reading. Basically, it means you figure something out without somebody coming out and telling you. You take all the clues to the situation, and you figure out what's going on your own. Notice the question, though. It says, which is the best inference about what happened? So one of the things I'm bad to do when I take tests is sometimes I know the right answer right away, and then as I read the other choices, I start to talk myself out of the right answer. When I see another one, I'm like, oh, maybe that did happen. This is one of those times. Let's look at the choices. Puddle was there, and afternoon it was gone. What's the best reason for this? F, it was very cold throughout the day. G, it was sunny and hot throughout the day. H, the water rolled down a hill. J, it was windy throughout the day. Did you see the crazy one? Yeah, the water rolled down a hill. Okay, that's not, didn't even say there was a hill. Now, get rid of H. One of them would not be the reason the water would disappear. If you know about what makes water seem to disappear, it's actually still there, you just don't see it now because it's in gas form. You know that evaporation is caused by adding heat. So we can get rid of F, because if it was cold, that wouldn't make it evaporate. Which leaves G and J. It was sunny and hot throughout the day. J, it was windy throughout the day. You may remember from our experiment in class that when we had a cup of water sitting out and a fan blowing across the air above the cup of water, that really made it evaporate faster. But notice that it says, what's the best inference? What's the most likely thing that caused it? Probably G. It was sunny and hot. We know for sure that warm temperatures can speed up evaporation. But what I do on J, this is how I always did when I was taking tests, I'd say, if it was windy, that could make it go faster. And then I start arguing with myself and talk myself right out of the right answer. Don't do like I used to do. G is the best choice. Now, turn to page 68 and do number 11. Number 11 is an example of one that I think is harder than what you'll see on TCAP, but I just want to see how you do on it. Pause the video if you need more time. Number 11 says, which of the following is an example of a change from a vapor to a solid? First of all, vapor means gas. So one of these is a vapor turning to a solid. Of those choices, hail, frost, salt, and ice, one of them is crazy. This doesn't even make sense. Which one is the crazy one? Yeah, C, salt. Anyway, so it's hail, frost, and ice. Now, one of these was actually one of the examples we used when we were talking about where a vapor turns straight to a solid. You may remember that on our red and blue chart we made for state changes, we actually drew a picture of this. Yeah, we said that when we have a gas going straight to a solid, our example was frost in a freezer. When you open up the freezer door at the house and then the warm air with water vapor from the rest of the kitchen gets trapped in the freezer when you close it, and it'll turn straight to solid. It'll skip over the liquid and go right to solid, forming frost inside your freezer. Notice that hail and ice, they're both solids, but they're not vapor going to a solid. They're actually liquid going to a solid. And so the best choice on this one is B, frost. Now, I would be very surprised if you were asked anything like this on TCAP, because the SPI says to know the difference between freezing, melting, and evaporation. However, it didn't hurt you. It's going to only help you when you do hard ones like this. Now, let's go to page 75. 75 says, what causes the particles of a substance to condense? Write your answer, and then restart the video when you're ready to go on. Let's look at the choices. The particles have lost energy, gained energy, disappeared, or reproduced. You see the crazy one? Yeah, reproduce. That's real crazy. We've not talked about that at all. And then disappeared, some kids think they disappeared, as in they're really gone, but that doesn't make sense either, that they just disappeared. That doesn't make something condense. So that leaves losing energy or gaining energy. First of all, condensation. Do you remember the definition? Condensation is when you have a gas and it goes to a liquid. Now think which is faster, gas or liquid. Particles in gas move faster. So if I've got a gas, the fastest particles turn it to a liquid, which are slower particles. Do I need to speed it up or slow it down? Yeah, I want to slow it down, so I'm trying to make it turn back to a liquid with particles to be slower. To slow it down, do I need to give it energy or take energy away? Yeah, take energy away will make it go slower. If I give it energy, it's going to go even faster. So number 31 should be A, the particles have lost energy. Here's our last practice one. I love this question. It says, look at the picture. What could you do to increase the rate at which water will evaporate? First of all, it says increase. That means go up, and rate means speed. Yeah, we want to speed up the evaporation. First of all, do you see one that's wrong? Our choices are cool the bowl, cover the bowl with a lid, pour the water into a wider bowl, or pour the water into a narrower, taller bowl. We want to make evaporation happen faster. Tell me one that will not make it go faster, and actually make it slower. A, cool the bowl, definitely make it go slower, right? Evaporation is caused by giving it heat. If we cool it off, it's going to make it go slower, but we want it to go faster. Cover the bowl with a lid will also make it go slower, because remember, the air that's above the water, if there's a lid on it, that's a limited amount of water vapor that can fit in that air. And then D, pour the water into a narrower, taller bowl. Where does evaporation happen? Yeah, the surface. So if we make a It's a very small surface, that same amount of water. There's not as many molecules at that top layer where evaporation happens. So C, pouring the water into a wider bowl will make evaporation go even faster. Now, take your pencil and draw a box around all of your practice ones that you did. Then on your paper, in that same section where you're working, numbers 6 through 15. So it'll be 6, 7, 8 through 15. Remember, don't skip lines because you're going to need lots of room to fit other sets on there. Beside that section, after you've numbered 6 through 15, let's put the SPI number. It's SPI 9.3. That way, if you want to redo on this SPI, you'll know which one it is. And then finally, let's put the page numbers. Pages 51 through 54. Remember to start with number 6. There's a 1 through 5 in that section. We're not doing that one. 6 through 15. There are a couple on there that are a little harder than usual, but don't worry. If you get them right, it's going to bump your score up even higher. That'll show that you have advanced understanding of state changes.